let's not forget that when we do integration and when we find these antiderivatives, we can also use antiderivatives to find definite integrals using the fundamental theorem of calculus. So this substitution process works with the fundamental theorem of calculus as well. One thing I want to warn about is that you need to be careful when you're doing substitution because the bounds that you use are with respect to a certain variable. If your integration starts with being integrated with respect to x, and you change over your integration to be an integration with respect to u, then your bounds could change. So be careful about the bounds and which variable those bounds are with respect to. Let's take a look at this example. We'll use substitution to evaluate this definite integral. We want to integrate 100e to the 0.10x with respect to x from 1 to 4. Remember, that's finding the signed area between 1 and 4. In this case, notice this is e to a linear exponent. I could, if I wanted to, do this problem by taking 100 divided by 0.10 e to the 0.10 or just 0.10 x plus c. And then that's the antiderivative or the class of antiderivatives. Since I'm doing a definite integral, I can let my constant be 0 and then plug in 1 and plug in 4. I want to emphasize this bounds argument though. So instead of just using my shortcut trick that I learned earlier about linear u's, I'm going to go through the entire process. I'm going to let u be equal to 0.10x. That means du with respect to x is going to be 0.10. And that means du is equal to 0.10 dx. And that 1 over 0.10 du can replace the dx. If I do that with a definite integral and I do my substitution, when I substitute a u for a 0.10x and I substitute a 1 over 0.10 for, 1 over 0.10 du for my dx, the bounds are no longer 1 and 4 because now we're using u. Now, most of the time, we just leave off the bounds or we pretend that they've changed. If I wanted to be precise, if my bounds were x values from 1 and 4, if I would replace the x with a 1 and then replace the x with a 4 in this exchange equation, technically speaking, the bounds here would be 0.1 and 0.4. I really don't need to know them though. That's my point. I don't need to know them at this point, even though they are these two numbers. Because eventually what I'm going to do is I'm going to take my antiderivative or an antiderivative, which is 100 divided by 0.10 e to the u plus any constant. Again, I'm going to let my constant be 0 since it's a definite integral. And I'm going to have two bounds. I can leave these off. Again, I know that these bounds in this case are 0.1 and 0.4. But when I do my back exchange, in other words, when I exchange back and make everything go with respect to x, then my bounds go back to 1 and 4. So in the middle, they change over to bounds with respect to u, but at the end, they change back to bounds with respect to x. So normally what happens is that while people are doing this, they just ignore the bounds when they're dealing with u's. And then when they exchange back in terms of x, then they put the bounds back on. And that's what I'm going to do moving forward. So we have a definite integral 100 divided by 0.10 e to the 0.1 multiplied times 4. And then minus that same thing but instead of plugging in a 4, we're going to plug in a 1. We're going to have to do that on our calculator. I don't know it quite yet. By the way, if you would have rather written that, I keep writing 100 divided by 0.10. If that bothers you, feel free to write 1,000. In fact, while I type it into my calculator, I am writing 1,000. I ended up with approximately 386.65. Again, that's rounded to 2 decimal places. This is how we deal with definite integrals. We essentially do the same process that we've been doing earlier, but you have to be careful that when you're doing things with respect to u, just leave off the bounds until you back substitute and put things back with respect to x. You could figure out what these are with respect to u, but it's really not worth it. Kind of the old saying goes, the juice is not worth the squeeze. Well, in this case, finding the bounds with respect to u is not worth the squeeze. I would like you to try to use substitution to evaluate this definite integral. So use substitution along with the fundamental theorem of calculus to evaluate this integral. Push pause on the video and then try it. In the next video, I'll show you how it's done.